25 seconds and counting, and Apollo 13 is go. T-minus 20 seconds, T-minus 20 seconds and counting. 17, guidance release, 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13. The Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
This is Mission Control Houston. We appear to have a good first stage at this point. Flight Dynamics Officer says the trajectory looks good. We show a 1/2 mile in altitude at this time.
13 Houston, go at 30 seconds.
Roll complete and we're pitching.
Roger that. Stand by for mode 1 Bravo. Mark 1 Bravo.
1 Bravo. Command.
Altitude 1.2 miles, velocity 1,500 feet per second.
On April 11th, 1970, 3 men climbed atop a pillar of fire, fueled by the peak of American confidence and the quiet rhythm of a space program that had made the impossible look routine. They were bound for the lunar highlands of Fra Mauro, chasing geology and a third consecutive conquest of the moon, unaware that a microscopic flaw was already ticking deep inside their ship. It was a mission that began with the roar of a Saturn V and the cheers of a nation, but it was destined to end as a desperate, silent struggle against the cold mathematics of the void. This is Apollo 13.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
We could have lost O2 tank 2. We got to get a pressure readout on that thing.
Houston, we've had a problem. Those 5 words are perhaps the most famous understatement in the history of human exploration. They weren't screamed in a panic. They weren't delivered with the cinematic flair of a Hollywood thriller. They were spoken with the clipped, professional detachment of a man reporting a minor sensor glitch. But when Jack Swigert uttered them on the night of April 13th, 1970, he wasn't just reporting a problem. He was announcing the beginning of the most harrowing survival story ever recorded. At that exact moment, 3 men, Jim Lovell, Jack Swigert, and Fred Haise, were 200,000 miles from the surface of the Earth. They were hurtling through the vacuum of space at thousands of miles per hour in a machine that was rapidly bleeding to death. Within seconds of that call, the mission shifted. It was no longer about geology or flags or the Cold War space race. It was about whether 3 human beings would become permanent satellites of the moon, drifting forever in a cold metal tomb. But to understand the miracle of their survival, we have to look at a moment of profound heartbreak that happened just days before launch. It is one of the great ironies of the space age. The man who was supposed to be on that ship was grounded by a childhood disease, and the man who took his place was the one who inadvertently triggered the disaster. The original crew of Apollo 13 consisted of Commander Jim Lovell, Lunar Module Pilot Fred Haise, and Command Module Pilot Ken Mattingly. They had trained together for thousands of hours. They moved as a single unit, knowing every switch and circuit of their spacecraft. But 7 days before liftoff, the backup Lunar Module Pilot, Charles Duke, came down with the German measles. Because the crew had been training in close quarters, NASA flight surgeons realised that Mattingly, and only Mattingly, was not immune. Fearful that he would erupt in a fever and spots while 200,000 miles away in a cramped capsule, NASA made a brutal decision. Mattingly was grounded. In his place stepped the backup command module pilot, Jack Swigert. It was a logistical nightmare. Swigert had to be integrated into the crew in less than a week. Jim Lovell initially resisted, protective of the synergy his team had built, but the clock was ticking. On April 11th, it was Swigert who strapped into the seat meant for Mattingly. As the Saturn V rocket roared off the pad, Ken Mattingly stood on the ground, watching his ship leave without him, devastated by a twist of fate. He thought his role in Apollo 13 was over. In reality, his most important work, and the survival of his friends, would depend entirely on his presence on the ground. To the world watching at home, the launch was flawless. By 1970, the moon had started to feel ordinary. The American public, once glued to their television sets for Apollo 11, was beginning to view moon missions like bus schedules. They were predictable. They were expensive. And to a world dealing with the Vietnam War and social upheaval, they were starting to feel repetitive. In fact, during the mission's evening broadcast just hours before the explosion, none of the major television networks, ABC, CBS, or NBC, even bothered to carry the feed. The astronauts were performing science demonstrations in zero gravity, showing off the interior of their ship, and nobody was watching. The world thought space travel had been solved, but space is never solved. Space is a high vacuum, high radiation, zero gravity environment that is constantly looking for a single point of failure to exploit. And on Apollo 13, a chain of invisible mistakes, made years before the rocket even left the pad, was about to remind the world just how fragile our bridge to the stars really was. The disaster didn't start in the vacuum of space. It started in a factory on Earth years earlier. It started with a 65-centimetre difference in filter shapes and a ground test that ran a few degrees too hot. During a pre-flight countdown demonstration, an oxygen tank, identified as tank number 2, had failed to drain properly. To fix it, engineers decided to use the tank's internal heaters to boil off the remaining liquid oxygen. It seemed like a standard workaround. What they didn't know was that a design change years earlier had upgraded the spacecraft's power system from 28 volts to 65 volts. But the thermostats on those internal heaters had never been upgraded. They were still rated for the old 28-volt system. For 8 hours on the ground, those heaters ran at full blast. The thermostats, designed to protect the tank from overheating, fused shut under the surge of power. The internal wiring reached a staggering 1,000 degrees Fahrenheit. The Teflon insulation on the wires baked, cracked, and flaked away, leaving raw, exposed metal inside a tank filled with pure oxygen. It was a ticking time bomb. It sat through the launch, through the climb into orbit, and through the first 2 days of the journey. It was waiting for a single spark. That spark came 55 hours and 54 minutes into the mission. The crew had just finished their boring television broadcast.
Apollo 13, Houston, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks.
Okay. Stand by.
Ground control in Houston asked the crew to stir the cryogenic tanks to get an accurate reading of the levels, a routine housekeeping task. Jack Swigert, the man who wasn't even supposed to be there, reached out and flipped the switch for the fans inside Tank 2. The fans spun, the exposed wires sparked, and the oxygen tank didn't just leak, it ruptured. The pressure from the explosion was so violent, it blew the entire side panel 4 off the service module. In the vacuum of space, there is no sound, but the crew felt a dull bang and a shudder that rocked the entire stack. On the ground in Houston, the data screens went haywire. The main B bus, one of the ship's primary electrical arteries, showed a massive voltage drop. Jim Lovell looked out the left-hand window and saw something that chilled him to the bone. A gas of some sort was venting into the blackness of space. It looked like a white frost shimmering against the stars. It was their oxygen. It was their power. It was their life. The command module, named Odyssey, was the only part of the ship with a heat shield. It was their only way to get back through the atmosphere. But Odyssey was dying. Its fuel cells, which combined hydrogen and oxygen to create electricity and water, were failing because the oxygen was gone. Inside Mission Control, the atmosphere shifted from confusion to a cold, calculated desperation. This was no longer a science mission. It was a rescue operation where the rescuers were 200,000 miles away. Flight Director Gene Kranz, famous for his white vest and iron discipline, locked the doors. He told his team to work the problem. Don't guess, don't panic. Look at the data. The data was grim. They had roughly 15 minutes of power left in the command module before it went completely dark. If the computer died before they could transfer the navigation data, the crew would never be able to find their way home. They had to move. They had to treat the lunar module, Aquarius, as a lifeboat. This is where the successful failure began to take shape. The lunar module was a thin-skinned, spider-legged craft designed to support 2 men for 2 days on the lunar surface. Now it had to keep 3 men alive for the 4-day journey back to Earth. But as the crew floated into the lunar module and began the process of shutting down the command module, a new realization set in. The arithmetic of survival was working against them. The lunar module had its own batteries, but they were never meant for a long-distance marathon. To make the power last, they had to turn off almost everything. No heaters, no guidance computers, no non-essential lights. The spacecraft became a refrigerator. The temperature inside plummeted to 38 degrees Fahrenheit. Condensation began to form on every metal surface, every wire, and every instrument panel. The crew couldn't sleep because the cold was so biting. They couldn't eat because their food was frozen. They were shivering, sleep-deprived, and rationing their water to just 6 ounces a day to prevent the ship's cooling system from failing. And then the invisible killer arrived, carbon dioxide. Humans exhale CO2. In a small, sealed environment like Aquarius, that gas builds up quickly. If it isn't scrubbed from the air, the crew would experience headaches, then confusion, then a quiet, permanent sleep. The lunar module had scrubbers, canisters filled with lithium hydroxide to clean the air. But they were only designed for 2 men. With 3 men breathing, the canisters were saturating. The command module had plenty of spare canisters, but there was a devastating engineering oversight. The command module canisters were square, and the lunar module's intake was round. In one of the most famous moments of the mission, engineers on the ground were given a frantic ultimatum: find a way to fit a square peg into a round hole using only the items currently on the spacecraft. The trench at Mission Control dumped a pile of equipment on a table: plastic bags, cardboard covers ripped from flight manuals, suit hoses, and duct tape. They spent hours prototype testing a bizarre, boxy contraption. Once they knew it worked, they read the assembly instructions over the radio to the freezing, exhausted astronauts. Jack Swigert and Fred Haise taped the cardboard and plastic together, shoved it into the round hole, and watched the CO2 levels on the gauges begin to drop. It was a triumph of improvisation over catastrophe. But surviving the air wasn't enough. They were still on a trajectory that would miss the Earth. After the explosion, the ship's path had been slightly altered. if they didn't perform a burn of the lunar module's engine, they would miss the Earth by thousands of miles and drift into a permanent orbit around the Sun. Doing an engine burn is usually a precision task handled by a guidance computer, but the computer was off to save power. To align the ship, Jim Lovell had to manually pilot the craft using the only two landmarks he had, the Earth and the Sun. He had to keep the Earth perfectly centred in his window, while Fred Haise and Jack Swigert timed the engine blast with a stopwatch. If they were off by a second, or if the ship drifted by a degree, they were dead. They fired the engine. They held the Earth in the window. And for a few seconds, the tiny engine of a moonlander pushed a massive, broken spacecraft back toward home. As they looped around the dark side of the moon, the crew became the furthest human beings from Earth in history. They were 248,655 miles away, staring at the cratered lunar surface they were supposed to walk on. For Jim Lovell, this was his second trip to the moon, and he knew it would be his last. He was staring at the greatest prize in exploration, knowing he would never touch it. They weren't explorers anymore. They were castaways in the deepest ocean imaginable. While the crew suffered in the cold, the grounded Ken Mattingly was living his own nightmare in a simulator at Houston. Because Mattingly knew the ship's electrical system better than anyone, he was tasked with a task that seemed impossible: finding a way to power up the cold, dead command module using only the tiny amount of energy left in the lunar module batteries. Mattingly went without sleep for days. In the simulator, he tried sequence after sequence. If they turned on the radio too early, the computer would crash. If they warmed up the thrusters too late, they would freeze. Mattingly had to find the exact Goldilocks path, the sequence of switches that would bring the ship back to life without blowing the fuses. The man who had been grounded by a disease was now the only man who could build the electronic map back to Earth. As they neared Earth, they had to move back into the command module, Odyssey, and pray it would come back to life. This was the ship that had been dead for days. This was the ship with the potentially cracked heat shield. If the explosion had damaged the thermal protection on the bottom of the craft, they wouldn't even feel the end. They would simply turn into a streak of plasma in the upper atmosphere. Using the sequence Mattingly had perfected on the ground, the crew flicked the switches. The ship groaned, the screens flickered, and Odyssey woke up. It was a miracle of engineering. A ship that had been frozen and dead was functioning again. They jettisoned the service module first. As it drifted away, the crew finally saw the damage with their own eyes. An entire side panel had been blown out, with wires and insulation trailing like internal organs. "Man, that's unbelievable," Haise whispered. They had been riding a bomb. Then they jettisoned their lifeboat, the lunar module Aquarius. "Farewell, Aquarius, and we thank you," Mission Control radioed. They watched the little ship that had saved their lives disappear into the darkness. Now it was just the three of them in the tiny, cramped command module. They hit the atmosphere at 25,000 miles per hour. The friction of the air turned the heat shield into a glowing furnace of 5,000 degrees. Outside the windows, the world turned a violent, screaming orange. This is the blackout. The heat is so intense it creates a shroud of ionized gas around the capsule, blocking all radio waves. Normally, for an Apollo mission, this silence lasts about 3 minutes. The world held its breath. On the deck of the USS Iwo Jima, sailors stared at the sky. In Houston, Gene Krantz stood at his console, unmoving, his eyes fixed on the clock. 3 minutes passed. Silence. 4 minutes passed. Still silence. The tension in mission control became suffocating. Every second that passed without a voice meant the ship had likely burned up or the parachutes had failed. The shallow angle of their re-entry, a result of their improvised navigation, was extending the blackout. At 5 minutes, even the most veteran controllers began to look away. At 6 minutes, nearly double the normal time, the silence was deafening. And then, a crackle of static.
Odyssey Houston standing by, over.
Okay, go.
Okay, we read you, Jack.
Okay, Joe. Swigert's voice came through, calm as ever. High above the South Pacific, 3 massive red and white parachutes blossomed against the blue sky. The capsule splashed down within sight of the recovery ship. Against every law of probability, against the cold math of oxygen and power, they were home. Apollo 13 never reached the moon. It didn't collect a single rock. By every technical metric of the original mission plan, it was a total multi-million-dollar failure, but it is remembered as NASA's finest hour. Why? Because it redefined what success looks like. It proved that the most important component of any spacecraft isn't the Saturn V rocket, the titanium hull, or the cutting-edge computers. It is the human capacity for reason under pressure. It was the success of a culture that refused to accept the inevitable. The mission forced NASA to undergo a brutal self-examination. They realised they had become overconfident. They spent months redesigning the oxygen tanks, moving the internal fans, and adding an extra emergency battery to the command module. They changed the way they trained, creating even more grueling failure simulations for future crews. But the deeper legacy of Apollo 13 is cultural. It showed us that exploration is not a straight line of triumphs. It is a jagged path of mistakes, narrow escapes, and hard-won lessons. It reminded us that when we go into the unknown, we are taking our fragile, fallible human nature with us. Jim Lovell later remarked that when he looked at the Earth from 200,000 miles away, he realised that heaven isn't a place you go when you die. It's a place you are born into. He saw a blue and white marble hanging in a void that was utterly hostile to life, and he realised how lucky we are to have it. For 1 week in April 1970, the entire world stopped fighting. People in every country, of every political stripe, looked up at the same moon and waited for the same 3 men to fall back to Earth. In that moment, the problem wasn't just NASA's, it was ours. And the solution, a mix of high science, duct tape, and sheer human will, remains the gold standard for what we can achieve when we refuse to give up. Apollo 13 wasn't just a mission. It was a masterclass in the successful failure. It showed that even when the machines break, and even when the math says you're dead, there is always one more thing you can try. And sometimes that one thing is all you need to get home.